Hello, everybody. Welcome to a fantastic Friday of math. So I'm really glad that you're joining me for math today. And without any further ado, let's get started. Okay, so grab your math sheet if you're using one, whatever device you're using to do your math, get it organized, find a quiet space, and focus on this video. I'm here to help you if any questions come up, but please watch the video and it should make it pretty easy for you to understand what we're doing. Again, if you have any questions, we are covering new material this week. So you can always shoot me a message on Teams and say, help! Please be specific. What day do you need help with? And what question, what part of the sheet? Okay, so even send me a picture when you ask for help. That's helpful because sometimes I get, and this is fine, but often I'm getting questions like, I need help with math, but I'm not sure what day, so I can't really help you. So send me a picture of the part that's giving you trouble if you have an issue, and I will be so thrilled to help you make this Friday fantastic by getting all your math done for the week and feeling so accomplished. All right, you think I've had enough coffee? I think I'm ready for this. Let's go. Well, hello there, grade 5. Let's work on our math for Friday. So this is your last math day of the week. Let's get it done so you can enjoy your long weekend. Okay, here is a bar graph of how much money the grade 5 class fund raised for a class trip. So here's the trip fundraising, amount of money raised in dollars, week 1, week 2, week 3, week 4. All right, so what week was the most money raised? Well, with a bar graph, the tallest bar means it's the highest amount. The amounts along the side. So week 1 was the week where the most money was raised because there was $42 raised in week 1. How much money was raised in week 3? To sort of figure that out, I'm just going to zoom in a bit. You go to week 3, you look at the bar and you see where it lands and you go across. $22. $22 was raised. 22.00. Okay, and how much money was raised altogether? So to do that, we need to figure out each week and add them up. So the first week is 42. The second week, we'll follow it along, 36. The third week, follow it along, 22. We already did that one. And the fourth week, I'm going to follow this line here. I find it helpful to put my pen on it, 14. So now I have to add, I'm sorry for my messy. I'm going to add these all together. So I'm going to start with my smallest amounts. 14 plus 22, okay, so 36. Okay. And then I just added these two together. So 14 and 32, or 22 is 36. And then I have another group of 36. And 42. So I put these two together because it was an easy number to add in my head. And now I don't have 4 numbers to add. I only have 3 numbers to add. So 6 and 6 is 12. 13, 14. So that's a 10. And the 10s need to go up there. So I have 4 1s and 1 10, and now I have 3 and 3 is 6, 7, 8, 9, 10, 11. 114. So all together they raised $114. You don't need to make your zeros small. It's a habit that I have. You don't have to do that. You could also write it like this. Your decimal point can go on the bottom. It doesn't need to be floating. It's a habit I have, and I catch myself doing it all the time. It's from when I used to work in a store, and we used to write everything fancy like that. All right, how much more money was raised in in week 1 than week 4? So we look at week 1, 42. We look at week 4, 14, and we need to subtract. We need to find the difference. So I go 42, subtract 14, and I look, all right, I'm going to have to regroup. 12, subtract 4 is 8. 3 10s, subtract 1 10 is 2 10s. So there's a difference of $28 between week 1 and week 4. You could also go here and count up to 42. That's another option. Okay, Thursday, on to Thursday. Now I know that's confusing, but grade 5s get to do all the days every week. What unit of measure would you use to measure the capacity of a juice carton? So juice cartons aren't often a whole, you might have a liter, but usually they're milliliters. So it's usually around, a bigger one might be like 850 milliliters, 750 milliliters. Juice cartons are often in milliliters. I guess you could get a big jug that could be 2 liters, but I go with milliliters. 2, 90 kilometers equals how many meters? So there are 1,000 meters to 1 kilometer. Okay, so I'm going to have to times 90 by 1,000, which means all I do is I write 90 and I go 90,000. And I don't know how we're supposed to write that in this tiny line. Like, I know I can write small, but that's pretty small. So 90,000 meters. Okay, now the next one, it's asking me to turn 27.1 meters into centimeters. Now to do that, we times, so 1 meter equals 100 centimeters. So this one has a 0.1. To multiply 0.1, any decimal points, by 100, you just move the point. So let's write this out here. So you have 27.1, and I'm just going to put, remember there's zeros on the end? Okay, those zeros are always there, but we don't always write them. So they're always technically there. Past the decimal point, those zeros go on forever, because you can break that number into smaller and smaller pieces. What we're going to do is we're going to move the decimal point 2 places, because it's 100. So I go 1, 2. So it's 2,710. 2,710 centimeters. And centimeters literally means 100th of a meter. Kilometer means 1,000 meters. Kilo is 1,000. Centa is 100. Okay. I don't know if that helps you understand it, but it's good information to have in the back of your mind. What time is it? What's the time, Mrs. Oakes? So I look at the clock and I look, okay, it's not quite 9 o'clock, so we're still at 8, right? Because this 9 o'clock, it would be pointing directly at 9, and this hand is there. It looks like it's 9. If this hand is there and it was in the 9 o'clocks, it would almost be pointing to 10. So it's 8, and then we count by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. It's 8:55. 8:55. John's desk surface is about 40 centimeters long and 40 centimeters wide. What is the area of the desktop? So we're going to be looking, remember when we do area, it's length times width. So it's about 40 times 40. So to do 40 times 40, do 4 times 4, which is 16, and then you just add 2 zeros. 40 times 40, cm squared, which of course means centimeters squared. So it's 1,600 centimeters squared, which means that you could fit 1,600 little tiny squares in there that were each a centimeter. Or if you had centimeter blocks, which are like those ones, you could fit 1,600 on there. Okay, let's practice long division. With remainders, this says there's a remainder. I know there's going to be a remainder because 25 is not going to fit evenly into this. So I'm going to start by estimating what would be reasonable. So I'm doing 25. Okay, well, there's 4 25s in 100, and this is almost 600. So you could fit almost, not quite, but almost, what's 4 times 6? You could fit almost 24 groups of 25. I think it'll be less than that though, because it's not quite 600. And let's begin. So I'm going to start, because I know it doesn't go into 5. It's so 0. I'm going to look at how many times does 25 go into 59. That's 2 times. 25 times 2 is 50, which gives me a difference of 9. Okay, how many times does 25 go into 9? It doesn't. But if I bring down this 4, it goes into 94, and 25, I'm just going to write this here, 25 times 3 is 75. 25 times 4 is 100. So it's times 3. So it divides 3 times. 25 times 3 is 75. And now we have a remainder. So my remainder, okay, 94 subtract 75 is 19. Because think 95 subtract 75. Okay, let's just do 8. 14 subtract 5 is 9. 8 tens subtract 7 tens is 1. So just so you guys know, I'm not just making those numbers up. I'm doing it in my head. By looking at 94 is almost 95. 95 subtract 75 is 20. And then one more or one less would be 19. So that is my remainder. I cannot fit 25 into this 19. So I write remainder 19. All right, on to the next one. 35. How many times does 35 go into 553? Sorry, shouldn't say the and. 553. So it goes into 35 goes into 50 times. 35 goes into 55 one time. 1 times 35 is 35. Subtract. Now I have 20. 35 does not go into 20. So I have to bring down this 3. Now here is where it's going to get a little bit tricky, because you're going to have to estimate how many groups of you're going to have to do your 35 times tables, but you have to estimate where to start. So it's 35 times 10 is 350. So it's going to be less than 10. Okay, sorry, I'm going to backtrack a bit because my thing stopped recording. So I look here and I'd said you need to estimate. I'm not sure where it stops, so I'm just going to start back here. So 35 goes into 203 how many times? So first, and I already did this part, so pretend it's not there, but I estimated how many I thought. So I thought, okay, 35 times 10 is 350, so it's less than 10. So half of 350 would be 5 times 35 is 175. All right, well, I need to figure out it's not 175. So I went up to the next one, which was adding 35 to that, and it's 210. So 6 times 35 is 210. That is too high of a number. So it is 5. 35 times 5 is 175. Now we do some good old subtraction. So you could start at 175 and count up to 203, or you could do it Grandma and Grandpa's way. It's totally up to you. And I am going to do it Grandma and Grandpa's way. I know that the difference is 28, but I'll model Grandma and Grandpa's way. Can't do that. So I break up my 100 to 10, break up my 10. Now I have 13. 13 subtract 5 is 8. 9 subtract 7 is 2. And 100 subtract 100 is 0. So I have a remainder of 28. All right, now I understand this is something new. We've done remainders and we've done long division with 2 digits, but we've not done 2 digits with remainders, and it's okay. All right, now we are going to move on to this one. How many times does 20 go into 270? So I know that 20 goes into 2 0 times. I look at my next number. 20 goes into 27 1 time. 20 times 1 is 20. I'm going to subtract to get to 7. 20 does not go into 7, so I'm going to bring down this 0. 20 goes into 70 3 times, and then 20 times 3 is 60. Now I subtract to find a remainder of 10. Okay, I hope that I caught that, and I hope that my camera is rolling, and we're going to move on to the other side. So now, the long-awaited practice of subtracting fractions is what waits on the other side today. And what we're going to be working on, so we added fractions we composed and decomposed them. So which means we made them and we broke them up. And now we're going to subtract. So it says, now that we know how to add fractions, subtracting will be easy to learn. Let's use this visual model to help us solve this equation. So 6/9 subtract 2/9 is how many? So first we're going to shade 6/9. 1, 2, 3, 4, 5, 6. Okay. And now it's telling me to erase 2/9 of the shading. Now I did this in pen, so I'm just gonna, which is a little bit confusing, but it's just us. You guys can figure it out. So now, how many 9ths do I have left? I have 1, 2, 3, 4 9ths. It does even say with a pencil. I need to learn to read the directions. So how many 9ths are still shaded? 4 9ths are still shaded because these ones pretend we erased them. So this is what I have left. I have 4 9ths left. Okay, how many? So 2 9ths subtract, or sorry, 6 9ths subtract 2 9ths is 4 9ths. I'm going to actually use a pencil and an eraser for this. As much as I love my special pen, I'm going to grab a pencil and an eraser, and we're going to do this using a pencil and eraser because it'll be easier. So I'm going to zoom in, and this one, let me just see. I'm going to do the first row, and you are going to do the second row all by yourself. So the first row you can do with me, and then I want you to try the second one on your own because I know you can do it. So let's start with this one. So I have 10 12ths. So I'm going to shade in 10 12ths. And then I'm going to subtract 4 12ths. So I'm going to erase 1, 2, 3, 4. So how many 12ths do I have left? 1, 2, 3, 4, 5, 6. It's almost like 10 subtract 4 is 6. Almost. All right, on to the next one. So I have 6 6. This is my whole thing. And I'm going to subtract 3. Okay. These are still shaded. So now I have 3 left. Now my next one, I have 5 5ths, which is this whole shebang, this whole thing. So the whole thing is shaded, and I'm going to subtract 2. 1, 2. Okay, so 5 5ths subtract 2 5ths is 3 5ths. All right, on to the next one. 7 10ths. So 2, 4, 6, 7. Subtract 4. So I'll erase 4. 1, 2, 3, 4. How many do I have left? I have 3 left. 7 subtract 4 is 3. So that makes sense. Just like adding, our denominators are staying the same. We're just dealing with these numerators. Now, you guys get to do the next ones by yourself, and I would like to see a quick snapshot of your work if you can send it to me. And what we're doing is you can make this model if you want, or you can just do it in your head, but the denominators are staying the same and we're just subtracting the numerators. So 2 subtract 1, guys, is 1. And again, I can do it so I make 2 and I subtract 1 if I want, and then I have 1. Okay, so you do that. Now it says create your own subtraction equations and draw a picture to accompany it. I'm going to do one, you're going to do one. So I'm going to draw a chocolate bar. It's totally a proper rectangle. And then I'm going to break it up into 4 pieces. So I have 4ths. And I'm going to do 1, 2, 3 4ths. Subtract. I'll do 1/4. 1/4 equals 2/4. And I can check that that's correct by looking. 3 subtract 1 is 2. I got it. Now this one, you are going to do one on your own. Then you're going to send it to me because I'd love to see your work. Okay? And the next one, subtracting fractions without visuals. So it says, subtracting fractions with the same denominator can easily be done without drawing a picture or using a visual model. You just subtract the numerators. Take a look below. So it says, when we subtract 4/8 from 6/8, we know that the denominator stays the same. We are subtracting eighths, so the answer will also be in eighths. So 6/8 subtract 4/8 is 2/8. Then we just subtract the numerator. 6 subtract 4 is 2, so the numerator becomes 2. And this denominator, this bottom number, he or she or it stays the same. Okay? So now it's saying check the equations using a visual model. I've learned for subtraction I need a pencil. So we're going to start with 1, 2, 3, 4, 5, 6/8. So hopefully that's easy to see on camera. And I'm going to subtract 4 of those. 1, 2, 3, 4. Okay. And I have 2/8 left. Yes, that is correct. Now let's move on to here. So remember, just like the other day when we were subtracting, we were adding without visuals, this is the same deal. So your fraction, your denominator stays the same. So that's not going to change. I can write that right away. And I go 7 subtract 6 is 1. Okay, now we're doing 10/11ths, subtract 4/11ths. Okay, my denominator stays the same. 10 subtract 4 is 6. Okay, and I look here, tenths, 8/10ths, subtract 5/10ths. Well, 8 subtract 5 is 3, so 3/10ths. So I look here, 7/10ths, subtract 1/10. I know it's going to be a tenth. 7 subtract 1 is 6. Okay, I'm going to go through the next row, and then you're going to do this one on your own. Okay. Let's get going. So this one is 11/12 subtracts 3/12. So I put 12ths because I know my denominator is going to be a 12th, or I know I'm subtracting in 12ths. 11 subtract 3, so again, I count back or whatever you want to do that. So I've got 10, 9, 8. 8 to 12. Next one. 8/12 subtract 5/12. So it's going to be a 12th. 8 subtract 5 is 3. Next one. 4/6 subtract 6/6. I know it's going to be, 2/6. I know it's going to be a 6. It's a 6th. 6 is on the bottom. 4 subtract 2 is 2. All right. Last one of the row, and then you're going to try the rest on your own, okay? So I'm going to go through this one step by step. First, I read it. I go, okay, 7/8 subtract 2/8. I know I'm working with eighths, so I just put this here because that I know isn't changing. My denominator is staying the same. Then I go 7 subtract 2 is 5. That's all you have to do. So for all of these, your denominator is going to stay the same. This one's going to be over 8. This one's going to be over 5. And you can figure out the last two, and then you just subtract the numerator. So 5 subtract 3, 3 subtract 1. Simple subtraction that you've been able to do for your whole grade 5 career. All right, it says make the differences below by filling in the blanks for each fraction. Make the differences below by filling in the blanks for each fraction. Okay, so something subtract something is 3. It has to be less than 7. Well, I could do 6 subtract 3 is 3/7. Done. Okay, I have to equal 2. I could do 4/5 subtract 2/5 is 2/5. 3, it has to equal 3/9. I could do 6/9 subtract 3/9 is 3/9. Okay, this one has to equal 2. I could do 5/7 subtract 3/7 is 2/7. So all I'm doing is I'm looking at this top and I'm going 5 subtract 3 is 2. 6 subtract 3 is 3. 4 subtract 2 is 2. 6 subtract 3 is 3. Now, do you think it matters if I had done something different? Maybe I had done 5/5 subtracts 3/5. If I still get to the 2, it's still correct. Okay, so I'm going to do 2 more with you, and then I'm going to have you do the last 2 on your own. So my difference is 1. I could do, okay, what's something that equals 1 when you subtract it? I could do 4 subtract 3 equals 1. 4 6 subtract 3 6 equals 1 6. Last one I'm going to do with you guys, 4 tenths is what I need to end up with. So I could do 6 tenths subtract 2 tenths. 6 subtract 2 is 4. I'm good. Now the last 2 you're going to do on your own. So you get to make up equations for these 2, and you get to do this row up here. Okay, so that's what I want to see. I want to see your work for this page. If you can send it to me, that would be excellent. All right, that seems to be the end of your math for this week. More math coming at you next week. See, that wasn't so bad. It's all done. You're done your math for the week. You can go into your long weekend feeling accomplished and fantastic and just proud of yourself for all the work you've done this week. And in general, you're working really hard and I appreciate you showing up. So remember, you can send me a picture of anything you're having trouble with and ask me for help. I'm here to help and I'd love to help you. If not, just send me a picture of your completed work and I will be happy to get that too. All right, have a beautiful long weekend. Thank you for all your hard work and I will see you next week on Wednesday for more math.